Hello everyone. Now I will explain an example. We have a gas, 2 moles. It expands slowly and adiabatically from pressure of 5 atm, and initial pressure is 5 atm, and a volume 12 liter. And to a final volume is 30 liters. And we shall find what's the final pressure, P2. What are the initial and final temperatures, T1 and T2? We shall find the Q, change in internal energy, and work for the gas during the process. So let's find first of all the final pressure. We know it's a adiabatic process. In adiabatic process, we can write this formula: P1 V1 in gamma equals to P2 V2 in gamma's power. And what is the gamma? There is given that the gas is diatomic. It means that gamma equals to 7/5. It means 1.4 since it's diatomic. So here we can find P2. P2 equals to P1 multiplied by V1 gamma and divided by V2 gamma. So if you will calculate, P1 is 5 atm, V1 12/30, and it's in power of 1.4. So it equals to actually approximately 1.386 atm. This is our pressure, final pressure. So we found the pressure, so let's find the first, the initial and final temperatures. We know the formula PV and RT. So by this formula, we'll find our temperatures. T1 equals to P1 V1 over NR. N1R. It doesn't matter. Why? Because initial and final mole is equal to each other. It's N1 equals N2. It is 2 moles. So we'll just take 2 moles equals to P1. So 5. We should change it to pascals. It will be 5 multiplied by 10 in power of 5 multiplied by V1. V1 we should change to a meter cube. It will be 12 multiplied by 10 power of -3 divided by 2 and 8.31. So T1 will be equal to 361 kelvins. This is of initial temperature. And T2 is actually with this formula, P2 V2 over NR. P2 is we found 1.386 multiplied by 10 in power of 5 multiplied by 30 and 10 in power of -3 divided by 2 and 8.31. And it will be equal to 250 kelvins. We found the initial and final temperatures. So what about the Q? Q will be equal to 0 since it's an adiabatic process. And delta E initial we'll find by this formula. Since it's a diatomic, it will be 5 divided by 2 and NR T2 minus T1, change in temperature. So delta E initial equals to 5, N is moles 2, R 8.31, T2 is at 250 minus 361, and it will be with minus sign. It will be minus 4,612 joules. This is our change in internal energy. And by the first law of thermodynamics, we'll find how much was work done by this process. And Q is a 0, so the initial plus work, and work equals to minus delta initial. It means that work is 4,812 with a positive. So we found the pressure, temperatures, Q, delta and W, work. So thank you for watching. That's all. So goodbye.